Okay, so let's start from the beginning then. So during our experiment, we determined the mass of the water by taking my mass of my calorimeter on its own and subtracting it from the mass of the calorimeter plus water. I have to consider my uncertainties. My uncertainty for the scale that I used was 0.001. Because I'm subtracting, the rule says if you add or subtract, you have to add your uncertainties together. So I'm going to add the 0.001 and the 0.001 together to give me 0.002. This means if I refer to the mass of my water, the mass of my water could be 109.979 grams plus 0.002, or it could be 109.979 minus 0.002. Do you understand? My variation can be between those values. I do the same for temperature. We got our initial temperature and we got our final temperature. I used the normal thermometer. Those were my uncertainties. To get my temperature change, I will take my final temperature minus my initial temperature, and I will get an answer of 12.4 degrees Celsius. My uncertainty for temperature, because I've subtracted, I have to add my uncertainties together, which means my final temperature will be 12.4 degrees Celsius plus 0.2, or it could be 12.4 degrees Celsius minus 0.2. Do you understand?
Yeah.
Okay. Now, I need to determine how much heat was transferred by the burning spaghetti to the water. I'm not really worried about the mass of the spaghetti at this stage. All I need to know is how much heat was transferred by burning that spaghetti. So I will use the equation, and this one is very important. It's topic 5.1. Q is equal to MC delta T. To use this, I will look at what was heated. I heated the water. So I need to know the mass of my water that was used, which I have over there. I'm going to use the specific heat capacity of water as 4.18 joules per gram per degree Celsius. And I'm going to use my change in temperature, which I determined here to be 12.4 degrees Celsius. So let's substitute that into the equation. The mass of my water was 109, and now I don't include my uncertainties in my calculation. It's 109.979 grams multiplied by 4.18 joule per gram per degree Celsius multiplied by a change in temperature of 12.4 degrees Celsius, right? If I do this calculation, I'm going to get an answer of 5,700.432 joules. I can write this. That's it. I have to write it as 3 sig figs because the least sig figs that I have is 3 sig figs. Rayan, how will we write this as a 3 significant figure value? Right, what is the answer?
Because you can't do it to 3 because of like the zeros, you can do 5.7 times 10 to the power
5.70 will give me 3 sig figs. So it's 5.70 times 10 to the power of 3 joules. That's writing the answer correct to the correct significant figure. You have to make sure that you do this correctly. If we look here, we have 6 significant figures. Here we have 3 significant figures. And here we have 3 significant figures. That's why the final answer has to be in 3 significant figures. I will be looking at that very carefully, so make sure that you don't make that mistake. Do you have any questions about this and the calculation? These calculations are in the test as well. Yes?
Some groups have like a For the water, they measured the water each time.
The aim for this experiment is for you to use your experimental data to find out how accurate is your data to the experimental value or to the values given to you by the manufacturer. So let's quickly look at that now. So our experimental value, let's first see, we need to look at what was the mass of the pasta that we burned. So we need to know the mass of the spaghetti. In my case, the mass of the spaghetti or pasta was 1.149 grams. Again, my scale is plus minus 0.001. That's my uncertainty. The next thing that I also had to do is I had to get the mass of the leftover. That's that little piece that you didn't burn. In the experiment I did, the mass of my leftover pasta was 0.053 grams of pasta, again plus minus 0.001. And just like we did with determining the mass of the water, I have to determine the mass of the burnt pasta. And I will do that by taking my 1.149 grams and subtracting 0.053 grams from that, which gives me a mass of 1.096. I then have to consider my uncertainties, and just as before, I'm going to add the uncertainties together, right? So these two uncertainties here will become 0.002 because I'm subtracting. It means that the mass of my pasta could be 1.096 plus 0.02, or it could be 1.096 minus 0.02. So it's plus or minus 0.002. At my final mass, I will indicate my final uncertainty. Just like in the previous one, when we look at the final mass of our water, it's 109.979 plus or minus 0.002. And I do the same for my temperature, plus or minus 0.2. We've determined, in my case, that 1.096 grams of pasta was combusted. That's the amount that was combusted in this experiment. Now, again, I need to look at my sig figs, and then I need to also do comparison. So let's quickly look at, I want to know how much energy is in 1 gram of pasta, right? So I've determined, and we choose another color, that 1.096 grams of pasta is going to produce, according to my calculation here, 5.70 times 10 to the power 3 joules of energy, right? It will produce 5.70 times 10 to the power of 3 joules of energy. That's according to my calculations that I have now. But I don't want to know how much is produced by 1.096 grams. I want to know if I had 1 gram of pasta, how much energy. So that's X joules of energy is it going to be. So if I'm going to solve X is going to be equal to 5.70 times 10 to the power of 3 divided by 1.096. Do you understand what I did? Who don't understand what I did?
I understand.
It's cross multiplication. So I will close this. If this is X, I close this, and then X is equal to the leftover multiplied with each other divided by that which I'm closing, that which is opposite x. And that's going to give you an answer of 5.20 times 10 to the power of 3 joules. So now I've determined how much energy is in 1 gram of pasta. I need to know how much energy is in 1 gram. Okay, so 10 to the power of 3 times 10 to the power of 3. Yeah, this is multiplication. You guys use dots and I get confused with all the dots. So I make a cross, not an X. If I make an X, I make it like that. Any questions? Okay, so for the next step is to compare it to the manufacturer.
Witness, can I check the paper?
So to compare it to the manufacturer, there's a few things that you need to remember that's important. That is that 1 calorie, which is nutritional calorie, is equal to 1,000 calories, which is the heat calorie. Now, if you look at the pasta, the box, okay, so I use the pasta and I'm going to use my theoretical value. According to the manufacturer, the theoretical value is 200 calorie. So the manufacturer said to me that I have 200 calories of energy in the pasta. And he gave me this value as 200 calories per 56 grams on the box. That's from yours is different. I'm not going to use the same. So the first thing you need to do is you need to convert the theoretical calorie given by the manufacturer to heat calories. How will we do that?
Multiply it by 200,000.
So 200 calories, which is the capital, I have to convert that. So I will have capital calorie at the top, and I have small letter calorie at the bottom. I have small letter calorie at the top because I want to know how many heat calories that is. According to this, 1 nutritional calorie equals to 1,000 heat calories. So that means in 200 calories, you are going to have 2,000 heat calories. 200,000. But I also need to convert this to how much energy is that. So we know that 1 calorie is equal to 4.18 joules of energy. 1 calorie is 4.18 joules of energy. Because according to the specific heat capacity of water, you have 4.18 joule per gram per degree Celsius. That's where I get it from. That 1 calorie is equal to 4.18 joules. So that means if I want to put this into energy for joules, I will say that 1 calorie, small letter C calorie, times 4.18 joules will tell me that I have 836,800 joules of energy per 56 grams of pasta.
So then you divide it by 56, no?
So now you're gonna take the 56 grams and say, hang on, how much energy is in 1 gram? Because you have just determined How much energy is there in 1 gram of pasta by burning it? So now you can compare these two and then do your percentage errors. In the next lesson, I will focus on the percentage errors and the uncertainties and how to apply these uncertainties to this experiment. Okay?
Thank you, ma'am.